Hello student, today we are going to start a new topic, that is collision. It is part of work by energy, and over here we will study what is collision and what are different types. See, over here collision means what? There is two particles, they will collide with each other and there will be changes in the velocity. Now we have to take into consideration that there are two type of collision, that is elastic collision and inelastic collision. See, in the case of elastic collision, what happens that momentum before and after collision will remain same, means momentum is conserved in both the cases, in elastic collision and inelastic collision. Kinetic energy is conserved in the case of elastic collision, is not conserved in the case of inelastic collision. Total energy is conserved in the case of elastic collision, it is also conserved in the case of inelastic collision. Means everybody is following the law conservation of energy. See, what we have to learn over here is that if there occurs a collision, in the case of elastic collision, we have to find V1 and V2. See, let us suppose this is a elastic collision. See what will happen. Let us suppose there is one body, this is M1, there is another body M2 having velocity U1 and U2. They suffer a collision, and after collision they acquire velocity, let us suppose V1 and V2. See, our objective is to find V1, V2, which is the velocity of the body after collision. Since it is elastic collision, what will happen? The momentum will get conserved before and after collision. This is M1 V1 plus M2 V2. And since it is a elastic collision, total kinetic energy before and after collision will remain same. Means it is going to be this, half M2 V2 square. From here we will derive the third equation. It is derived from equation 1 only. What will take M1 common outside? This is U1 minus V1. This is will take this M2, that will be equivalent to V2 minus U2. This is equation third, which has been derived from equation 1. Similarly, we will derive equation 4th, which is derived from equation second. U1 square, V1 square, over here it is what? Half M2 V2 square minus U2 square upon 4. Since our objective is to find V1, what we have to do over here is that we will divide equation 4 by equation 3rd. See what will happen. This is half M1, this is what? U1 V1 whole square upon M1 U1, and over here is what? U1 minus V1. Here it is half M2, this is what? V2 square minus U2 square, this is what? V2 minus U2. See, half getting cancelled out, M1 with here, M2, and what we have, this is there, we had M2 also. See over here, this will be U1 minus V1, this will be U1 plus V1, and this will be what? U1 minus V1. And over here it is what? V1 minus U2, this is what? V2 plus U2 upon V2 minus U2. See, this get cancelled out. See, we are left with what? U1 plus V1 and V2 plus U2. See, utilizing equation 1, what is that? M1 U1, this is M2 U2, this is what? M1 V1 plus M2 V2. See, we have to find V. Our objective is to find V1. We will eliminate V2 using what? U1 minus U2 plus V1. Over here what we'll do is let's substitute the value of V2 in equation 1. See, this is m2. v2 is what? v2 will be, this is u1 minus u2, u1 minus u2 plus v1. See, our objective is to get v1. It is what? This is m1, this is m2. We have utilized v1. Now we'll take this m2 u2. This is m2 u2. It becomes what? Twice m2 u2. Now what we are left with? We are left with what? This is m2 u2. We have used this one, used out. This is used out. v1 is used out. v1 used out. We are left with what? u1, and this is m1 minus m2. See, we get the result as u1 m1 minus m2. This is twice m2 u2 divided by what? m1 plus m2. This is v1. See, what we do next is to get v2. It will be equal to u2 m2 minus m1. This is what? Twice m1 u1 upon m1 plus m2. See what happens in this case. There are few special cases we need to remember. What happens to the particle? Let us suppose this is case 1. Let us suppose m1 is equal to m2 is equal to m. See what will happen. It is case of elastic collision. What is going to happen over here? See, v1 will be equivalent to what? See, m1 is equal to m2. This get cancelled out. We are left with what? 2m divided by 2m. This is v1 is equal to u2, and v2 is going to be what? v2 just getting cancelled out. This is v1 is u1. Means in case of elastic collision, the body exchange their velocities if the masses are equal. Case 2, let us suppose this is m1 is equal to m2 is equal to m, and see u2 is 0. The second body is at rest. Then what will happen? v1 will be equal to what? See, second body is at rest, so v1 is going to be 0, and what is v2 is going to be? See, v2 will become this mass getting cancelled out, this 2m getting cancelled over this, means v2 is equal to u. These are the few cases we need to go through in the case of elastic collision in one dimension. Over here we had like there was collision between two particles, and we were supposed to find their velocities v1 and v2 after collision. We need to remember this final formula if they do ask certain questions in the examination. That's all for today. We'll meet in the next class. Thank you.